Assalamualaikum, I bid to Madam Nurul Aini. Today, our group will present the group project for STA 680 entitled Heart Disease Using Binary Logistic Regression. Our group consists of 3 people where it is including me, Muhammad Syami Afiq bin Ahmad Sanib, next Muhammad Amirul bin Azlam and Fakihah Syazwani binti Abdul Muttalib. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syami Afiq bin Ahmad Sanib. First and foremost, for the introduction, heart disease or cardiovascular disease are the most common cause of death around the world, with an estimate of 17.9 million of people died because of this every year, representing 32% of all global deaths. According to World Health Organization, coronary heart disease, cerebrovascular illness, rheumatic heart disease, and other heart and blood vessel problems are all classified as cardiovascular disease. Heart attacks and strokes account for more than 4 out of every 5 cardiovascular deaths, with 1/3 of these deaths occurring before the age of 70. According to Thomas R. Anderson in 2018, in type 2 diabetes, cardiovascular disease CVD is a prevalent comorbidity, and he stated that cardiovascular disease was the cause of death, representing 50.3% of all deaths.
Next, we move to the problem statements. In Malaysia, heart failure remains the principal cause of death for the past 2 decades. According to FMT Reporter 2021, Chief Statistician Malaysia, which is Muhammad Uzair Mahidin, said there were 18,515 deaths due to heart disease in years 2020, which is 68.6% of the total deaths is males, and the remains is 31.4% is females. And on top of that, there are common symptoms of cardiovascular disease. According to the World Health Organization in 2021, a heart attack or stroke could be the first indication of underlying disease, since there are no symptoms of underlying blood pressure and vessel disease.
The research objective for this study is to find the most significant factors to be included in the model, and the second one to predict whether the patient has a 10 years risk of future coronary heart disease. The research question for this study is, what are the most significant factors to be included in the model? Does the patient have a 10-year risk of future coronary heart disease?
Okay, next for the chapter 3 in the study, which is the methodology. The methodology in this chapter will explain the source of data and the method being used for the study. In this topic, binary logistic regression will be used to analyze and complete the study. All the steps will be discussed in this chapter in order to achieve the research objective. Finally, the data will be analyzed using the IBM SPSS statistic. So this is the research flowchart for our study, which we start with data collection, followed by data pre-processing, and next one is model assumption testing, also model fitting, model validation. Next, we will be starting the data analysis, and the last one is the result and conclusion. For the data collection, the study was committed by using secondary data to complete the analysis. The dataset was obtained from the Kaggle website, which named Heart Disease Prediction. The dataset is about prediction, whether the patient has 10-year risk of future coronary heart disease. The data is from an ongoing cardiovascular study on residents of the town of Framingham, Massachusetts. The data consists of over 4,000 observations and 15 attributes, where the attributes divide by 2, which are 8 quantitative variables and 7 qualitative variables. Next, for the data pre-processing. It is the process of converting raw data into a clean data set. This process consists of several steps including data cleaning and data transformation. This procedure is required to avoid misleading results. Missing value is defined as the data value that is not stored for the variable in an observation. This occurrence will result in invalid conclusion and biased estimation. Next, for the outlier. An outlier is a data point that differs significantly from other observations due to its abnormal distance from other values. In addition, it is important to provide data with no outlier, since the presence of it may cause serious problems in building a model. Winsorization transformation. It is a technique to cater to outlier by minimizing the influence of outlier. The common winsorization used is at the 5th and 95th percentile. In the model assumption, we have three components, which is the first one is response and predictor variable, the second one is outlier, and the last one is the multicollinearity. So for the first one, in binary logistic regression, the dependent variable y must be in binary response, which means there are only two outcomes, 0 or 1 or yes or no. In addition, the predictor variable x may have quantitative and qualitative variables. The second one is the outlier. The existence of outlier in a dataset can cause a serious problem as it may affect the fitness of the model. Therefore, outliers cannot be presented in this model. The last one, multicollinearity. It is a statistical condition where two or more independent variables in a regression model are highly correlated and dependent on each other. Multicollinearity can be checked using the variance inflation factor, or VIF, and tolerance. By using the VIF, it measures how much of the variance variation in one variable is explained by other variables. If the value exceeds more than 10, therefore the two variables are highly correlated. For the tolerance, it is associated with each independent variable and range from 0 to 1. Wexford and Britt state that a tolerance value lower than 0.2 suggests serious multicollinearity in a model. Next, for the model building where we use binary logistic regression. A member of a class of models called generalized linear model is logistic regression. The purpose is to estimate a regression equation that relates the expected value of the dependent variable for binary dependent variables. It was denoted by y to one or more predictor variables denoted by x. The log-IT natural logarithm of odds can be modeled by a linear regression model as the figure below. For the odds to probabilities, it will be easier to understand if it is in terms of probability. Thus, the log-IT or log odds can be converted into probabilities by p. By exponentiating, we obtain the figure below, which describes a logistic curve. The relation between p and predictor x is not linear, but has an S-shaped graph. The logistic curve in parameter beta 1 determines how quickly p changes with x.
For the quantitative variables, the table shows the descriptive statistic for potential risk factor for the prediction of heart disease. It can be seen that cholesterol level has highest with mean 236.73 compared to BMI, which is body mass index, with 25.08. The data for this study is 3741 observation, and there are totals of 497 missing value for the variables, and there are also 3741 observation for quantitative variables. Also, the percentage of female respondents is higher than the male respondents, and variable for current smoker has higher percentage for yes than no, while the other variables such as blood pressure medication, prevalent hypertension, diabetes, and 10 years of coronary heart disease have higher percentage for no than yes. Next, we move to the data pre-processing. For the univariate outlier detection, we detect that there are outliers for variable cigarette per days. We have 4 outliers, which is 2652, 2393, 1646, and 3242. And at variable total cholesterol, we have 2, which is 2780 and 995. And for the systolic blood pressure, we have only 1, 427. And for BMI, which is body mass index at observation, 2346. For handling this outlier, we decide to remove the observation since our data have a large number of data, which is the total over 4,000 something. That's why we remove the outliers and drop the observation. And for the multicollinearity, we detect there is no multicollinearity since the tolerance less than 0.2, and we can see the tolerance less than 0.2, and the variance inflation factor, which is VIF, is not exceed than 10. Therefore we can see there is no multicollinearity. Okay, next we move to the binary logistic regression. And for model of evaluation of the validation, the first table was case processing summary, and we detect that there are 3741 cases in this study. And for the variables in equation tables, we can see that the B is equal to negative 1.018, and we use odd to probability formula, which is the result is 179 will be having coronary heart disease, while 100 will 1000 will not be having coronary heart disease. Okay, next we move to the odd ratio. For odd ratio, there are only 3 variables that are significant, which is the value is less than alpha, which is 0.05, and therefore the number of cigarettes per day, total cholesterol levels, and glucose level will be in log expression. And this is our equation for log expression as below. Next, we proceed to our next process of model evaluation of the validation. First table, it was omnibus test. In omnibus test, the model coefficient, the chi-square value is 370.756 and has a significant value, which is the value was 0.000, which is less than our alpha, 0.05. Thus, the null hypothesis will be rejected, and it can be concluded that there is a significant relationship between dependent variables and the set of predictive variables. And next we proceed to the model summary. The model summary, we can conclude that 16.4% of total variation in 10 years coronary heart disease will be explained by all the predictor, while the balance 83.6% will be explained by other factors. And lastly, for Holmes and Lemeshow test, it can conclude that the model is fit as the significant value, which is 0.226, is more than our alpha, which is 0.05. Therefore, we can conclude that the model is fit for the data in this study. Okay, next we move to the model evaluation of the validations. There is tables of classification tables, and we begin 3 calculations. And the first one was apparent error rate, which is APER, and we conclude that there is 15.21% in this study were misclassified, which is less than 20%. Therefore, we can conclude that the model is good. And for the next calculation was overall success rate. We have shown the calculation below. We can conclude that the ability for the model to predict accuracy of both positive and negative outcome is 84.79%. And the last one, sensitivity and specificity. Based on the results of ability for the model to predict sensitivity or predictive positive outcome, is there is no ability for sensitivity, while the ability for model to predict specificity or to predict negative outcome is 100%. Therefore, the model is better on predicting the negative target, since the value of specificity is higher than sensitivity. For our next model evaluations, the picture shows the how we conclude the Hosmer and Lesmes-Howe test, and it shows that the model is fit, but the classification plot indicates the model is not good model because the distribution does not scatter around 0 and 1, and the graph scatter decline, and it shows negative relation.
Prediction of new observation. Let's say a person who will have an average of 6 cigarettes per day, have no glucose level, and his total cholesterol is 215. Is the person going to have a coronary heart disease in the 10 years? Well, we can use the Logistic model that we get just now, and then let's see for the probability is 0.9689, which is more than 0. Therefore, the person will have coronary heart disease in the 10 years. According to the study, as has been notified, heart disease is a common causative for the increasing number of deaths related to the heart cases. In this study, the objective is to find the most significant potential risk factors that will contribute to the heart disease, using medical data of patients with a history of heart disease. Along with the finding, we can fulfill the second objective, which is to predict whether the patient has 10 years risk of coronary heart disease or vice versa, by using binary logistic regression. Since the finding and analysis of study for multivariate analysis using IBM SPSS statistics have been found out that the correlation matrix shows that there is no multicollinearity since the value of tolerance is less than 10. Thus, the assumption of the multicollinearity were fulfilled. Besides, the Hosmer and Lemeshow were conducted to test the goodness of fit. Well, the result shows that the model has an adequate fit to the data, since the Hosmer and the Lemeshow test of goodness of fit is not significant by using alpha 0.05, and the value was 0.226, which is more than the alpha itself. The value of Nagel curve R squared is 0.164. Based on the result, we can assume that 16.4% of the total variance in the 10 years of coronary heart disease will be explained by all the predictors that have been provided. To be concluded, from the overall analysis, the model can be used as prediction in the patient having the 10 years risk of future heart disease. The significant factors included in the model for the prediction are the amount of cigarettes taken per day, glucose level, and the total cholesterol. As for the recommendation for future research, using different methods to predict coronary heart disease in 10 years and compared with the binary logistic regression. By comparing, we can get the most accurate prediction. Besides, adding different input variable will have a different result, which will affect towards the prediction of coronary heart disease in 10 years. Adding different input variables due to the changes of the human habit within the 10 years, it can help to make the research better. Last but not least, future researchers should use other techniques besides the Winsorization to cater the outlier.